So what happens to a blown balloon if you heat it up?
It expands.
They got blown.
I think the balloon will rise, like go up.
If you increase the pressure of a container of a gas, what happens to its volume?
Pressure of a container gas?
The gas, it's gonna move faster, so it's gonna expand.
It will add volume.
Yeah, volume.
It will increase the volume.
The volume stay the same?
If you have nitrogen and you apply a lot of pressure to it, what will happen to the temperature?
Temperature goes up.
Pressure. Then what happens to the temperature? It gets colder.
They increase.
First problem, what happens to a blown balloon if you heat it up? The answer is that the volume increases, and this is because of something called Charles' law. So what is Charles' law? It's a law that states that the volume and temperature of a gas are directly proportional, given that the pressure and the amount is constant, and the gas is an ideal gas. So if we write this in formula, we get something like this: V1 over T1 equals V2 over T2. And so in the context of this specific problem, since the temperature has increased, to keep the equal sign the same, then the volume should also increase, and that is why this is the answer. For the second question, if you increase the pressure of a container of gas, what happens to its volume? So for this one, the answer is that the volume decreases, and this is because of Boyle's law. So what is Boyle's law? Boyle's law is a law that says that pressure and volume are indirectly proportional, given that the temperature and the amount is constant, and it's an ideal gas. So writing this in formula, we get that P1 V1 equals P2 times V2. And so also in this context of the problem, since the pressure increased, then the volume must decrease in order to keep the equal sign constant. And lastly, what would happen to the temperature of nitrogen gas if we apply a lot of pressure on it? So this answer is that the temperature increases, and this is because of something called Gay-Lussac's law. So what is Gay-Lussac's law? It's a law that says that the pressure and temperature are directly proportional if the volume and the amount of the gas is constant, and it's an ideal gas. And so if we write this in formula, this will be what we get: P1 over T1 equals P2 over T2. And since pressure increases in this problem, to keep the equal sign the same, temperature would also increase. And so that's why the temperature increases. And lastly, we now know Charles, Boyle, and Gay-Lussac's law, and we can combine these three to make a third law. And this is what we call P1 V1 over T1 equals P2 V2 over T2. And we named this the combined gas law because it's a combination of the Charles, Boyle's, and Gay-Lussac's law. And if you look closely at this law, you can see all three of these laws inside here, because if you take out the pressure, then it's Charles' law; if you take out the volume, it's Gay-Lussac's law; and if you take out the temperature, it's Boyle's law. That is the four gas laws that we've covered today, and thank you for watching.